Hello, I am Souvik Sen, a student of Netaji Subhash Engineering College. This is an already created simple half-wave dipole antenna. Today I am going to show you how to generate a report like this on simple half-wave dipole antenna. So we can select from excitation port 1. We can see the resistance and reactance values. You can use it in our lab report, and under analysis we can see the sweep, fast sweep, and the range 1 to 3 gigahertz. In the results we can see how there is a resonant frequency of M2, M3. From here we can see the lowest frequency, which is M1, which we get from here 2.19, is the resonance frequency. Lowest frequency is called the resonance frequency, and the bandwidth will be FH minus FL, which is a higher value minus lower value equals to bandwidth, and fractional bandwidth will be FH minus FL by FH plus FL. Here let us take FH equals to M3 value 2.49, and M2 value will be the FL value, which is 1.97. So FH minus FL by FH plus FL into 200 would be the fractional bandwidth. A normal bandwidth would be just FH minus FL. So from here, XY plot, we can also see the Smith chart, which gives us the Smith chart for reflection coefficient. In the XY plot 4, you can see the real part of reflection coefficient and the imaginary part of reflection coefficient with the frequency plot. We can also see the 3D polar plot of the simple half-wave dipole. We can see that it is very less in the z-axis and only along x and theta and y-axis. You can also see the radiation pattern inside the polar plot, which look like this, very low in the z-axis. This is the total gain in dB for phi equals to theta 0 degree and 90 degree. And this is for theta 0 degree and 90 degree also. And this is for phi theta degree, phi degree, phi 0 degree and phi equals to 90 degree. This is the XY plot 5, which is total gain sweep for phi equals to 0 and 90 degree, and this is for theta and phi both together. For port field display, we have to see the main we can see, it is going from here to here. It is very clumsy, but it is very low. As we can see from blue color, it is very low at the z-axis ends and higher near the x and y axis. We can include this all graphs like this and write under it what is the cutoff frequency, upper cutoff frequency and lower cutoff frequency, as well as the resonance frequencies, fractional bandwidths and bandwidths. Smith charts, the real and imaginary part graphs with respect to frequency. We can draw include these all. This is what I was going to show. As you can see, it comes from one end, the electric field, and goes towards the other end. We can see the magnetic field too. It radiates right from the center in a clockwise manner. So these all can be included in our laboratory report. We can also include the dimensions by going into HFSS and selecting design properties, and we can see all the design properties like RD, LD, D, AR, PR, CR, HRED, RD box, which have their username. There is no need to show the individual models parameters. You can only show it from HFSS and design properties. That would be enough. So this was my report generation video on HFSS of simple half wave dipole antenna. Thank you. I am Souvik Sen, a student of Netaji Subhash Engineering College.